here in this part you may get either 8 marks one question itself based on this state machine model only. Okay, so how, here you can see two main examples are there, one concept is there. So that's what seat belt wearing alarm in the car, seat belt wearing alarm. So alarm is generally off, driver will put a key, ignition will start, it will wait whether the driver try to move or not. Okay, if you try to move, within that time he should wear the seat belt, otherwise the time waiting time is over, alarm starts making a sound. After that also he can wear the seat belt, no problem. Once he wear a seat belt, alarm goes off. But thing is, making the driver to wear or put on the seat belt, that is what the concept is. Okay, so today's automotive like a car or something has gone many of the advances, like it cannot be moved further if he is not at all wearing a seat belt. Only after wearing a seat belt he can move, the vehicle will move. Okay, so you can see here. Okay, that's one. Idle time, right? Idle time. So then comes a load a timer and start a timing. So the person is, I mean the vehicle is ready, vehicle is ready, vehicle is not yet running because he has a I mean he has not yet wearing a seat belt. Once he wear a seat belt, now he can put up a gear up, and he can go further. So like this state, you can take any of the example, bike, car, etc. Okay, so this is one case study, this is one general diagram, right? Okay, now we have seen coffee vending machine in the last session. Okay, so how the coffee vending machine will work? Generally it is in an idle state, idle state. Okay, so once we put up a coin, it is in the active state, and it will give a menu whether you want a coffee or a tea. Okay, so if he presses T button, tea is dispensed, measured quantity, the quantity is already fixed, only that much quantity is uh, dispensed into the cup. Okay, so if we go for another option of coffee, so coffee will be dispensed, not the both. We have two options. If immediately after putting a coin, if we cancel a transition, he will come, I mean from active again it becomes sleep or inactive. Okay, if he removes a coin, or if he doesn't select no coffee, no tea, then also lazy state or idle state. Active state, it will be expecting a button from the user, either coffee or tea. So both the cases, after dispensing either tea or coffee, it should come back to the sleep mode. This is how the state machine diagram. You have studied similar concept in your previous semester, Murray model and Mealy model. Again, you have one subject in the next semester also. So there you are going to study much, but here that's it. So fine. This is one of the very, very important, I hope, 8 marks question. Public telephone coin box, we used to call in general words. It is called public telephone. I hope you all remember the coin box. Okay, so this is how it works. Slightly expanded diagram, so that students should practice this, right? First, let's understand what are the different states of this. State A, here, except state 1, I'm telling state A, it's a ready. Ready means maybe you have lifted the cradle. Okay, so then state B, waiting for a coin, right? States, you have inserted a coin. State C, waiting for number to dial. State C. State D, he started dialing 10 numbers, 10 different numbers he will dial. So state E, call in the process, that means the person is speaking. That's a state E. State F, call terminated. Okay, call terminated. State G, unable to make a call, when after the dial, After the dial, unable to make a call. That's a G. Correct. H, invalid number input. When invalid, waiting for a number. Instead of starting with the 8, 5, 6, some number, we might have started with A, B, C, D. So that's an invalid number. State, okay. The last, state 1, out of order. Out of order. So you lift it. Okay. So now, I hope you understood all the states. Let's go for edges of this FSM. So you will go to the public coin box. I hope nowadays we cannot see this component because everybody can manage their personal mobile. Still, a case study is there for us to understand. So we'll go to the coin box or the public telephone. We will lift it and we got to know that there is no connection at all. The line we used to call dead. So immediately we checked and it is in the dead state. That means out of order state. So we lifted that kernel and we got to know that, that receiver, and we got to know that phone is in a minimum state. I hope if we used to, whenever we pick that receiver, okay, we used to get some sound, that if no sound, it's called dead. If there was a small sound, then we used to call correct state. So now in mobile, it is not, we cannot hear that. Directly we'll go to contacts and press a button of call. Okay, but whoever have had experience of this, you can recall what happens if we use a land phone, how it works. Okay, so next is what we have lifted a receiver. So what is the event and what should be the output? We have lifted the receiver and we got a correct sound. That means the action is performed correctly, right? Performed correctly. Now, after listening the sound, we need to put a coin. We need to put a coin. First numbering, then coin, it's wrong. First coin we need to put, then go for number. So coin is inserted properly. That makes state C. That means wait for a number. Now, coin is successful means next person should give number. So now he starts dialing and he completed dialing. Okay, so complete dialing means D state. Okay, D state. So now what happens? Suddenly there are two options. What is the first option? Line successful, line unsuccessful, line wrong, not successful, unsuccessful. So if line is available, that means other person will receive and both started communicating with each other. So if line is busy, what happens? It will show person is not reachable. Person is not reachable. So if person is not reachable, what is the option we have? We have to place their receiver and immediately we'll get a cash out, that coin out. Action is return the coin for a user. If successfully line is available, that means both started communication. Okay, monitor the duration, 60 seconds. I hope you remember in 1 rupee, it was a 60 second, right? So 60 second is a duration. After 60 second, what happens? User need to put one more coin. Otherwise, place it again, make a connection. So if it is a timeout, okay, let's take only one attempt. So if it is a timeout, okay, so disconnect the line because 60 seconds was there, no? After 60 seconds, disconnection of the line. So then what happens? If the line is disconnected, keep the receiver on the exact position, right? Okay, so now if not timeout, okay, if not timeout, line has got a unexpected disconnection. Line has got unexpected disconnection. That also takes us to from E state to A state. Now my question is, okay, so here can the states B, C, D, E, F, G, H directly connects to state I or state 1? Not possible. Why? Because this, so state 1 and state A are, sorry, state A exists only when state 1 to state A is correct. That means if the line is dead, no person is going to lift the receiver, lift the receiver, put up a coin, dial, because as soon as he lift a receiver, he got to know that the phone is dead, so immediately he will keep the receiver back and he will go out. That means what? These all cases will not happen if the coin box is not in a proper condition of working. I hope you understood. Okay, it's a very simple. So now this one you need to practice. Okay, all this coffee winding machine, coffee or tea winding machine. Then comes the coin box or public telephone. Okay, what all the two concepts we have finished? One is data flow graph, and another one is a three subheadings in state machine. Shivanand, I am getting noise from your side. Shivanand, mute yourself. Otherwise, I will remove.
Yes, sir.
Okay. So one is a data flow graph and three subheadings in state machine. Now let's go for three more models in the computation. One is a concurrent, sequential, and object. Object is little lengthy. Concurrent and sequential are very easy. Okay. So here comes the fourth type of computational model. Okay, sequential model. So the sequential model here is your simple C program. How the program will work? It's starting from the state of okay, header file main function. Then comes like variables, local variables. Then subheadings of some printf, scanf. Then call for a user defined function if it is there. Then execution of it. Then finally the end. So meaning of sequential execution is there are set of activities which will execute one after another. So we cannot execute user defined function before the main. Always rule of a C program is it should start from main, one by one line execution, it continue. Like that is the sequential execution. Okay. So in the same way, can we explain the car seat belt in a sequential model? Let's see how it works. Start the car ignition. Let me elaborate. Okay. Start the car key. Okay. Wait for 10 seconds. If ignition is on, that means yes, you can see here in a small font. Yes. So check whether the driver is wearing a seat belt or not. If ignition is not on, that means off, no need to check because ignition is off. So no need to wear, there is no rule to wear a seat belt when ignition is off. If ignition is on, check whether he is wearing a seat belt. If he is wearing a seat belt, don't make any alarm because already he is wearing seat belt. If no, set an alarm for 5 seconds. Set alarm for 5 seconds. Okay. Within a 5 seconds, he should wear. Otherwise, what happens? Still ignition is on. Still ignition is on. Okay. And again, okay, if it is no, after 5 seconds, he is not wearing and ignition is not on, so we can forget it. But if ignition is on and after 5 seconds also he is not wearing a seat belt, make seat belt sound, make seat belt alarm. So then what happens? For about 5 to 10 seconds, seat alarm will make a sound. So 5 seconds after making alarm, if he wear a seat belt, that's done. Okay. But even after 5 seconds, he is not wearing alarm means, okay, there are, as I told, some car will give, they will only make alarm. After that 5 beep sound, so not, they will forget. I mean, that car will, it did its work of making the driver aware about not wearing a seatbelt. But nowadays, it is some step extra. Stop the ignition. What happens? Even after continuous alarm, if he is not wearing the seat belt, it will not allow for moving ahead, gear up. So that means here, stop ignition. I hope you understood now. But this is slightly moderate concept. So what happens? Make sound for 5 seconds. After 5 seconds, you can see here. time is expired. If time is expired, stop alarm. If time is not expired, and check whether is ignition again on, again seat belt is wearing or not. Like that, you keep on checking. So some of the car, they do sound continuously, even though it is idle, even though it is a moving. Okay, some of the car, today's car, they will not at all possible to move without wearing a seat belt. Some car not even make a sound. So this is all some possibilities, different concepts. This is one of the generalized execution. I mean, alarm method. Here, all these activities executed one after another. Maybe there are some loop back, loop ahead, but mode of execution is sequential. I hope you understood now. Now, how to explain the same concept with the help of program? See here, on means one, yes means one. I think it is a tautology. Okay, so tautology and contradictions. Off means zero, no means zero. Global variables. Okay, right. There is a function called seat belt warning. Seat belt warning. Wait for 10 seconds. Check whether the ignition key is on or not. If on, check whether he is wearing a seat belt. So ignition is on, seat belt is not yet wearing, starters alarm. Ignition is on, and also seat belt is on. So no need of checking what? No need of making alarm, because ignition is on, he is wearing a seat belt. If ignition is on and he is not wearing a seat belt, then we have to set an alarm. So now let me highlight this. Up to what time he can make a sound? That's what the concept here. Up to how much time the alarm can make a sound, right? Here you can see seat belt continuously off until he wear a seat belt, until ignition become off, means he will turn on. He is not interested to wear a seat belt, so he will turn off the engine. And also time expire, time is not yet expired, so till that you make alarm. If any one of the case happen, then you can go for stop of the alarm. Okay, so if he wear a seat belt, stop alarm. If ignition key is off, then stop alarm. Then if time expires, then also stop the alarm. I hope you understood now how the sequential model is. Okay, now comes the one more computational model, concurrent or communication processor model. So what do you mean by concurrent or communication process model is here. I hope you can see in this part. Okay, see now how we can explain in a better option is multiple programming or multi-thread options. I hope you know the IPC, inter-process communication also. Okay, so here how this inter-process communication will work each other at a time, so that driver is wearing a seat belt or not, that is checked. That is given a message with the ignition part. Okay, so whether ignition is continued or not, I hope you are getting. So both will give a message to alarm system, should it make a sound or not. Really speaking, alarm is in different part. Ignition takes place in the engine, seat belt is inside the driver cabin. Okay, but really they are far from each other. Ignition is outside the cabin, seat belt is inside the cabin. This alarm is somewhere middle of engine and the driver. Okay, so what happens? Ignition will check whether the ignition is on or not. Okay, if ignition is on, then next two works. First thing, alarm is on or seat belt is wearing or not. If seat belt is not wearing, it will give a message for alarm. Since ignition is on, seat belt is off, alarms should be ready to make a sound. Like that, this ignition set will give message to the alarm task. So what alarm will waiting for? Alarm has a reference of this. One reference is ignition, another reference is seat belt. Two reference. When alarm should make a sound, when this portion is on, that is key ignition key is on, seat belt is off. What do you mean by seat belt off? Not wearing a seat belt, ignition is on, then alarm should make a sound. Okay. So who is controlling the alarm work? Alarm control task will do it. Okay. What he will do? Alarm control task. He will make a sound for some limited amount of a time. Now the question, who will measure or who will calculate how much seconds control alarm should make a sound? 5 seconds, 10 seconds. Who will make this? So that is done by alarm timer task. This is a control task. This is a timer task. Next, all this, how much time alarm should wait so that user after ignition, user can wear a seat belt. This is called as wait timer task. So you will enter the car, you will put up, you will insert the key and you will start ignition. Okay. So now it should wait because you need 1 or 2 seconds to put up a gear and move ahead. Okay. So within that 2 seconds or 3 seconds, if we try to put a gear, then immediately it should make a mess. Alarm. It should inform alarm that he is trying to, since ignition is on, and the driver is trying to make a alarm right now. How much time to make alarm should make? Should it be 5-second alarm or continuous alarm like today's car? Okay, or no alarm like very old car, like that. That is decided by alarm timer task. Now, condition, I mean, what is important point from all of this is these all should execute concurrently at a time, and also they should communicate with each other. Okay, how they should communicate with each other is we have studied interface or communication protocols in the chapter 2 of this textbook or module 3, that is I2C, SPI, then a parallel interface, one wire technology, and some of the communication like a Bluetooth, Zigbee, Wi-Fi, IEEE 802.11, etc. So many we have studied. Okay, so among those, it should use any one communication protocol to make one system of this to communicate with other. The arrow mark here is very simple to draw in our graphic, I mean in our diagram on the paper. But really speaking, we should implement using one of the good communication protocol among whatever we have studied. So maybe the one wire technology or a parallel communication or SPI, any one model will be there for communication, because these are doing separate part of their work, but they should communicate with each other. Okay, so that communication is done by controlled by total embedded system controlling unit. Okay, I hope it is clear now with the concurrent and communicating process model. So here, what are the major roles of this concurrent and communicating process model is, one is making which process can execute parallelly. So now we can see here, can ignition and alarm and seat belt work parallelly? Among this, why alarm and seat belt are parallel and ignition is before in the diagram is because without the ignition, seat belt and alarm are of no that much important. They will get important only when ignition is on. As soon as ignition is on, alarm system is active and seat belt system is active. So what we can do, how to check? Today, if you have a car in your home, go inside the car and without a key or without a ignition, no need to wait for wearing a seat belt, no need to wait for any of the alarm. So there may be some other alarms which may give us indication of battery, fuel, etc. But with respect to seat belt, there may not be any of the alarm. Only the both system will active only when ignition is active. I hope it is clear now. Okay. So next comes what? One system should communicate with another. So one system should communicate with another within stipulated amount of time. It is not like after ignition, after starting a ignition, moving for 20-25 kilometers, then reminding itself that the driver is not wearing a seat belt. Let's generate the alarm. That is not a case. Okay, on time, within the stipulated amount of a time, the messages should be visible and communication should takes place. Only then we can expect a better output from the system. Okay, next here, so some of the sequential execution uh, directly leads into parallel. See here, what we expected is seat and alarm execution one after another. But really speaking, we can check them both parallelly, seat and alarm. Okay, so even though as soon as the driver starts the ignition, alarm system will also activates, seat belt system will also activates. Okay, so we can explain some of the models parallelly, and we can explain some of the models sequentially. Okay, so the last point is about object oriented model. I hope this concept is very, very simple for you in terms of your this one subject OOC, object oriented concepts. So here what happens, every concept is implemented in the name of object, real word object. You can see here real word object, they are well defined. Okay, so each object will have its features, okay, and functions. Okay, if there is an object called if there is an object called security or safety, so what are the its activities, which all parameters it should consider, how much safety it should provide, like that all the things are defined properly, and they are evaluated on time. Okay, in the same way, what happens is object oriented model. Okay, so since everything is in terms of object, we can easily define an object attributes and its function. We can merge few objects in some class. Okay, what happens for a class? It's a group of object where related objects will be doing same type of work on different data set. Okay, so member variable, how the class will work, it is based upon the member variables and its functions, okay, so like that most of the concept you know about this class abstraction is there, data hiding, it will provide protection, so one class referring another class. Okay, friend class, I think all these words you might have studied in your this one. Okay, so that finishes our chapter 7. So here we have a chapter 9. Before I could start chapter 9, some of the points I would like to tell you for